All right, 4D. This is a bit of a tricky one here. A good way to think of this one is annuities part 2. Okay, so it's like 4C. It's not really so much the opposite of 4C, but just an extension onto it. So what I'm going to do here is take a look at 4C and describe some of the stuff that we did there. And then that information hopefully will lay a foundation for what's happening here in 4D. All right, so to start off with here, let's recall what an annuity is, right? So if I'm going to call this annuities part 2, then we should have a good idea what an annuity is. All right, an annuity is a series of equal regular payments. Okay, the way that we looked at it in 4C was to put payments into a bank account and save money. Okay, so that's what we're doing in 4C is we're using equal size payments to save money. The important thing that we remember about 4C versus what's going to happen in 4D is that in 4C, we are saving money. We're putting money into the bank account. So the interest rate is working in our favor. We want high interest rates if we could, because the interest is accumulating more money within our account. And in 4D, that's going to be different. In 4D, we're going to be taking out a loan, and that interest rate in a way is sort of like working against us. We don't want the interest to accumulate because that means we have to pay back more. All right, so some of the big things that we did in 4C. We were developing formulas here. That was mostly intended just to show you how complex things were in this and to get a little bit of an idea of how that there's this building idea as we go through it. But there was two main formulas that we came up with. Okay, and they look almost identical to each other. You had this one, and what this formula did was told us if we had a certain payment that we were making with a certain interest rate, and let's see, we did it monthly, that was the end value. Okay, but if we were making a certain payment monthly, we would accumulate a certain amount of money at the end of whatever amount of time, Y, that we chose for here. Okay, so we could figure out if I were able to put $400 into savings and this was my interest rate, this is what I would have at the end of Y number of years for it. Okay, the next part was thinking, all right, what if my objective was to get to a certain number? How could I determine what the payment would be that I'm going to be doing here? I guess that's a couple pages later here. All right, so it's basically the same formula that we have here, or we had on the other page. The A and the payment have been switched in their spots, and to balance off everything here, this whole sort of complex looking part here, that was really, it's a fraction, just got flipped over. So if you multiply the overall amount that you want by the reciprocal of the fraction we saw beforehand, it actually backtracks and it tells you what the payment is that we needed. So we have an objective in mind, and we know and we can figure out the payment that we're going to need to accomplish that. Now, some of that stuff's going to look a little bit similar in 4D, except that 4D is going to be about taking out loans. Okay? So there's payments that you need to make each month. The payments aren't going to your savings account, but the payments are going to pay off some loan that you took out. Okay, but there's a similarity in here because there's a payment that we need to make each month, and there's an overall balance that we need to get to, which is the loan that was taken out. So when we do end up seeing the formulas for these, there we go. Let's take a look at this one first. All right, when we do end up getting to the formulas here, you're going to have one that outlines the payment for you that you want. So basically, capital P here is the amount of loan that you took out. So sort of like your capital A in the other one, but this is what you need to accumulate so that you can pay off the loan. And this overall formula here tells you what the payment would be that you need to make if you're going to be making, let's say, monthly payments. That's usually what it is for N, monthly payments for Y number of years to figure out what we're going to own or owe. Forget how to say that. What we need to pay to get to what we owe. All right, preceding that one ends up being a formula that we're not going to use too much, but it starts a process of understanding like how all this works. And it basically has the overall balance that we owe P and the payment switched. And the fractional part of this, if you take a look here, is pretty much the reciprocal. See, the APR over N is going to move to the bottom, and all of this with the 1 minus, etc., goes up to the top. Right, there it is at the top, and then the APR over N there. Okay. All right, so let's go ahead and start doing some of the problems that are in 4D. The first part of this is going to stage some problems that would make sense to you, like you can visualize this type of a situation, and what we're going to do is follow the numbers to see how this stuff works. All right, so for our first problem, it says, suppose that you borrow, well, it says you owe, so I'm going to say that you borrowed $10,000 and you got to pay it back, okay? Could be buying a car, something like that, and you financed at 9% APR. Okay, now what we're going to end up wanting to do is make monthly payments, and we're going to make a, does it tell us how much we want to do yet? No. All right, so we're going to try and figure out what the monthly payments are going to need to be so that we can pay off this whole loan here. Let me make sure that's right before I speak too soon. Yeah, we eventually get there. Okay, so what we look at first is just, look, monthly, what would be the interest rate that's accumulated on here? Because as you take out that loan, more money is being added onto because you're borrowing it. So we figure out our monthly APRs, and well, that sounds funny to say it this way, but because it's annual percentage rate. But what would be the rate of each month? Well, if you divide the 9% by 12, you're going to get 0.75. So it's 0.75%, which, let's add that little symbol in there, 0.75%, which is the same thing as 0.0075 when you are doing the calculations. All right, so let's see, how much interest will accrue on $10,000 loan during the first month? Well, if you didn't pay anything yet, it's just $10,000 sitting there. Then over the first month, if you multiply the 10,000 by the 0.0075, you figure out that it's going to be $75 here. Okay, so we conveniently set up the number so that that first month is going to be a solid number here. $75 is the amount of interest that you're going to gain on that first month. And you should take that in for a second there and understand like how large that is. And this is, some people do have this as a percentage like APR. So yeah, borrow $10,000 in the first month, 30 days, $75 just in interest. All right, question 3. I didn't quite like the wording of it, but what they want you to say is the $75 here. It says, what's the minimum payment that you can make the first month? And there's a lot going into the idea, so I think maybe it's hard to make the question as short as it needed to be, but what they want you to say here is $75, because as long as you pay off the $75, then it gets you back to the $10,000 that you owed. Right? If you pay less than $75, then you're going to end up with more than $10,000, which means the next month you're going to have an even higher interest rate, and you get in this like deadly, cycle of more money and more money and more money. I know there's some questions at the very end of the activity that will ask that whole thing there. All right, so you do need to pay off at least the interest rate. That's the big thing, at least the interest rate, and then it's not going to get worse for you. All right, so then 4 gets a little bit more into, well, we need to make some payments, right? We need to actually start paying this thing off. So let's pay $100. Let's pay $100 a month. See, the interest rate on the first month was $75. So if you pay $100, you're still making a dent into the loan that you had. $25 is all it is, but yeah, it's a dent. All right, so let's see. We're gonna start setting up like, month after month. What does it look like? All right, so at the end of the first month, there was the $10,000. $75 was interest added onto it, but you made a payment of $100. Which means that you actually made a dent of $25 into this whole thing, and now your balance has dropped down to $9,975. Not much, but it is less than what we had to start with. Okay, now here's where the numbers don't start looking as nice, and we're gonna have a lot of rounding going on here. All right, what would be the interest the second month? So the interest is not gonna be based on the balance you owe. It can't be based on the original $10,000 that you had because you don't owe that money anymore. So the next month, you're going to multiply 9,975 by your 0.0075, and you're going to get this as your interest. Notice it is just slightly less than $75 because that is just slightly less than $10,000. Okay, so less interest by what? A whopping 19 cents. Okay, so that is going to get added on, right? It's going to take you back over that $10,000, which is kind of crazy there, but it adds on to whatever your last balance was. But then we're going to subtract 100. So we have made another dent. We've made another dent of $25.19. Okay, so we're doing a little bit better this month. All right, then we'll repeat that process. We take this, we multiply it by your 0.0075, and you get a even smaller interest rate, just a little bit smaller, right? Okay, but that's going to get added on. Then you're going to subtract your 100, and now we're here at that value. Okay. All right, and then the writer of the activity was very nice to us and made sure that that they had the table filled out for us here. I didn't even notice it when I was working on it, but it confirms that we were doing a pretty good job with all of that. And then what we'll do is, so they even have the last number here, which is pretty helpful because I even made a mistake when I was doing the numbers here. I think I wrote like an extra 9 when it should have been 8, but it definitely helped me out to go through the next cycle or two and then figure out that this is where we are at the end of 5 months. All right, and what I wanted to do just in addition to this, so now we're getting an idea of just how it works, right? You gain interest, but then you pay a little bit more than the interest. You gain interest, you pay a little bit more, and slowly you start to make a difference as we go. Okay, what I wanted to say here, because I think it emphasizes the case pretty strongly here, is that definitely at the beginning of the loan, the first like couple of years of the loan, most of your money that you make in payments is going straight to the interest. It's going there. You're only like $75 to interest, $25 to the thing. So at the end of 5 months, I mean, really think that 5 months, you've actually paid $500. You've made 5 $100 payments to this thing. You've put out $500. But if you look at the difference between what that balance is and the $10,000, you've only actually paid off $126.90. So I added that extra bit of math in there, just to sort of emphasize like, wow, we really do pay a lot of money at the beginning, which is just straight interest, and you're not really seeing a change in your balance. It hasn't dropped by $500, it's only dropped by $126. All right, so now that we've gone through 5 months of calculations, and hopefully we get a feel for how this works, that interest is gained, you make a payment that's a little bit more than interest, then you reset and you just repeat that process every month. We now give you a formula here. Okay, here's a formula. And this one you're not going to use much. You're really not going to use this one too often here. This is a guessing and checking sort of method. The formula that you're really going to be interested in is the reverse one, which is at the bottom of this page here. Okay, so basically what this one does for us is it allows us to choose any amount of time in years for Y value, and it'll tell you how much money you have accumulated while that interest rate is working against you. This one's a tricky one, but it allows us to take the $100, the APR, which is the 9%, we're making monthly payments, so N is 12, and you can choose any year you want, and you can run a calculation and it will tell you how much you've accumulated. So if we can accumulate to the $10,000, then that would complete the whole situation. So what we're going to use it for here is a guessing and checking game. We're going to plug in different values for Y, different numbers of years, and we're going to look at the output. And once we get to $10,000, then we know that we found the right number of years that it's going to take to pay this off. Okay, now when I went through this, I kind of, I didn't really like cheat, but But I used the resources that were available, which is my graphing calculator. Let me see if I still have it in here. I think I do. Yeah, I do. Okay, all right, so apologize for that little delay there. Okay, so I was able to sort of cheat at the beginning, and I know I've mentioned this before in videos that the guessing and checking method is not, it's not something that I'm very fond of. I think there's some value to it, but don't worry about needing to do guessing and checking for a test. It's not a smart thing to put on a test because of time management type things. But anyway, what I did on the graphing calculator is I just typed it in, the formula filled in. So it's all these numbers filled in. We already knew what the percentage was divided, so I went with the 0.075 for each of those spots. I put a variable in for the y value, so that way on my calculator, I can look at as that number changes, what values I got. So then what I do is I go to a table that produces all these numbers. Right? So all the x's here are going to be the numbers of years, and the y values is going to be the amount of money that's accumulated, even though that interest rate is working against us. I would do that. So what I wanted to do was look at the y column and see when it gets to $10,000. So right now I'm at $7,800. All right, and we're moving, we're into the 9,000s. This one's pretty much right there. We got 9,859. So I go to the next one and figure out that I've hit the 10,000 mark, but I've actually jumped over that one. So in a way, I kind of cheated here at the beginning with using the calculator to find out that it's somewhere between 15 and 16 years. Okay, now it ends up that for the next couple of questions, you really needed to find exactly the number of months that goes along with it. So they gave you this hint over here that if you wanted to do 3 months, it's going to be 8 3/12. Okay, and sometimes those don't divide nicely here. Another way to write that, I mean, you have to have like a graphing calculator to make this one look pretty here, but you could write it as 8 plus 3/12. So if you have a fraction that doesn't divide nicely, like maybe 7/12, which is going to look kind of crazy when it divides out, you can actually just type it in as that number. But you'd have to have a resource, some sort of a calculator that does it. So anyway, what I did, so I knew it was between these two values. So I split the difference at 15.5 because that's 6 months. So I thought that was an easy one to type in, and found that that was too high for the 10,000 by just a teeny bit, there. Okay, so what I wanted to do then was back off 1 month because it's only over by $11. So if 15.5 is 6 months, 0.5 is 6 months over, then I wanted to do a 5/12. Let's see what that looks like in the calculator. So I took 5 and I divided that by 12. Yeah, so you don't really get a good looking decimal to use on this. So there's some issues with the problem, I know. Okay, but anyway, on my calculator, so if you haven't have a graphing calculator, here's a really cool thing that you can do. Just a little off topic, but maybe you know somebody who has one and you can show them this feature later. The formula, I have it saved under Y1. Okay, so if I'm on the home screen, there's different ways you can pull this up, but on the most recent 84s, if you type alpha trace, you can choose the function, you open parentheses, and you type in whatever number you want. So I'm going to do 15 plus 5/12, which is basically going to be 15 years and 5/12 of a year, or 5 months. And it will plug all that into the function on its own and give me back the calculation, which I got this. So what that told me is that at 15 years and 6 months, I'm slightly over. 15 years and 5 months, I'm slightly below. And we're not going to narrow it any further because we make monthly payments. So we don't care about the weekly stuff. Really what it tells me then is that at 15 years and 6 months, I have it all paid off, okay? But the final payment, see, the payment before got me all the way up to about $14, $13 shy of what I needed here. Is that right? Yeah, so then that last month is gonna not need to be a full-blown like payment on that. Okay. That was painful. I know. You're not going to be asked to do that again. And you might get totally stuck on the next couple of questions here. All right, 7. Why does the account balance decrease so slowly? I don't think that was actually described in what we see here, because unless you have enough trials that you practice, you're not going to understand what that question's going at. But what they're really thinking of when they wrote it is that you've got interest that's going on here. At the beginning, there's a lot of interest, right? Because if you think about the first page, $75 out of 100 went to interest. So even as you're making your payments, there's so much interest that's accumulating. It's going to take time to eventually start making a big enough dent in here. Now, the interest amount every month is getting smaller as you move along, so it does pick up some pace later on, but it is a pretty slow process, generally speaking. All right, getting back to what we did in the table here, this would have been really hard to figure out here. You have to make 186 payments. Okay, 185 of those payments are going to be the $100 payments, and then at the end there's this little bit of a difference that you still owe on it here. And what's really bizarre about this, and another reason I'm not a big fan of this formula and having us do this part here, is that it looks like that last $100 payment is getting you only about $14 away, but something in the math is a little bit different, and it turns out that your final payment is actually going to be $53.25. So I'm not going to go into the breakdown of like why that is, because that's super confusing, but here's what we end up with. Overall, what you end up paying is 185 payments of $100. So that'd be $18,500 with the 2 zeros added on, plus a final payment that the worksheet just tells you here is $53.25. So when you add that on, you get to a grand total of $18,553.25. And I don't know if it asks this question on the next page or something, but remember your loan was $10,000. That was your loan, was $10,000. So that means that in interest, you paid $8,553.25. Right, that's kind of crazy. So if you only wanted to make payments of $100, okay, here's a good way to summarize it. If you wanted to make payments of $100, it's going to take you 15 and a half years, almost, and you're going to end up paying $8,000 of interest. So you should probably make a payment of at least $200, and then it'll cut it down by more than half. It'll cut it down by a lot more, okay? You can see how it can get out of hand there. All right, look. Here's what we normally are going to do, okay? So if you didn't like any of that, scratch it. Here we are. This is the formula that we want to use. This is the one that finds the payment you need if you want to accomplish your loan in a selected amount of time. Right? You can't be paying off $10,000 for 15 years. That's like a house mortgage. House mortgages are 15 or 30 years, right? That's crazy, okay? For something that's about the price of maybe a used car. Okay, so let's do it different. Let's say, what if this was a used car, $10,000? You want to pay that off in 5 years. That's more reasonable. That makes more sense. Okay, so this formula is going to be much better for us because you get to choose that amount of time you want. You put it in for Y. The N is going to represent 12 because we're making monthly payments. There's another question where it's going to change the N value. I want to make sure that wasn't that one. Okay, so it is going to be 12 here. You got your APR, and you know what you borrowed, $10,000. So everything goes in, run the calculations, and it tells you that you can get this whole thing done in 5 years if you do $207.58. So a little earlier I said you probably shouldn't do $100, probably do like $200, and it'll cut it down by more than half. Look, if you do $207, it cuts it all the way down to 5 years, so a third of what we had before. Okay, so a little bit more at the beginning is going to make a huge difference later on. All right, so what we have next is a very good problem to like think about and run numbers with, and I think its application is very informative for us. It is a bit of a tough one though, because it is going to refer back to what was happening in 4C, and that's why at the beginning of the video I wanted to make sure that I at least talked about 4C and how that was about savings and this is about loans and all that. All right, so what we have here is a lady named Sherry, and she's planning for retirement. So we did a problem like this beforehand, but it's a little different now. She's going to start at 26, and she's going to save $50 from every paycheck, which she gets paid bi-weekly. Okay, bi-weekly. That means she gets paid every 2 weeks. So not like semi-weekly, twice a week, but bi-weekly means every 2 weeks she's going to get paid, which means like she does get paid like twice a month-ish. But what we're going to end up doing, I have it somewhere down here. We go ahead and assume that a year's worth 26 weeks, or I'm saying that a year's worth 52 weeks. So if you're going to get paid every other week, divide that by 2. That means she's going to get 26 payments, 26 paychecks. Okay, so from those 26 paychecks within a year, she's going to put $50 into a savings account. Let's see what else we got. It's going to be a 7% APR. That is, I don't know what kind of account she's putting it in. Oh, well, it's a 401k, but I still think that one's going to be heavily inflated from what we would really expect. But that's the rate that we're going to use here. And I think that's most of the information. Oh, there's a second part that's going to show up in a little while that she wants to live, or she's hoping she lives to the age of 100, which I assume is fine. Fine thing there. But so for 30 years, she's going to be retired, and she wants to be able to live off the money. Now, in a previous problem, we did a simplified version of it where we just wanted the money to accumulate interest forever. But in this case, she is willing to let that money to deplete down to $0. Guess she doesn't have anybody she wants to leave the money for, so she's just going to consume all of it at the end. So that's what's going to be different from what we had seen in one of the problems from 4C. All right, so there's 2 parts to the question. The first part is going from age 26 to 70. There's a certain action that's happening there, which is all the savings that she's doing. Then from 70 to our 100 age that we're hoping for, that is going to be a depleting of the account. It's taking money out and bringing it down to 0. Okay, so we got to handle these 2 different ways because just how they work, right? There's different situations. Like in, I know it asked the question, maybe it's on the next page here too. Like at the beginning, she starts with $0 and she's trying to accumulate money. All right, and then in B, she starts with the money she accumulated and she's getting it down to 0. Okay, so we're gaining money, we're losing money, sort of thing. Or giving and taking, however you want to say it. Okay, so the first part here, by the way, these boxes were a little bit confusing to me, so I had to go look up what they wanted for that part, but then it made sense once I saw what was needed for them. The beginning part is her savings process. She is going to be making regular payments. The balance is going to be increasing. Okay, now we got to find all of these values. But really, before you can find all these values, you needed to understand what the formula was that we're going to be using. Okay, and here it's mentioned in the middle. I kind of glazed over it myself. So we must use the savings plan formula. See the formula sheet? Well, I don't know where that one is, but it was in 4C. So you go back to 4C and turn that sideways for you here. It was this formula, the one that I was talking about a little while ago, where you have your payment, you've got your APR, all that stuff, and then this will tell you how much money you accumulate. So I'll pull that one up in terms of variables. Just a second. Okay, so it was this one, savings plan formula from 4C. And again, you don't need to memorize any of these. We'll give them to you. We'll give you the titles. What you are going to be responsible for understanding is what that formula was used for. And I think you have, it's only like 3 or 4 of them that you need to know. So it's not a lot of them, but practice will help you try and remember them. We'll give you the titles of them though too, so we're not trying to disguise anything from you. you're getting tested on the application of it, not memorizing it. All right, so things that we needed to know. One, this is going to be going on for 44 years. That's the 70 minus the 26. That's the 44 years. This is 44 years going on. This is going to be 30 years going on over here. All right, so 44 years, your APR with the decimal moved over is 0.07. Your payment's gonna be $50, and the number of payments, which I talked about earlier, is gonna be 26. That's a bit of a curveball because we're used to the 12, but with the bi-weekly, it's actually gonna be 26 payments throughout the year. And then the A value is what we're finding here. She's making all these payments, and eventually it accumulates to A. So I just put an X in that spot, didn't really know what to write there. It doesn't really go in the formula because you pack everything in and that's what it equals. It equals the A value there. Okay, so you do the whole calculation. I don't have that on my calculator because I've sort of cleared that part. But it accumulates to $383,844.25. So over 44 years, that $50 every other week has added up to that. Now, again, that rate might be a little bit inflated here, but over 44 years, it should accumulate a good amount. Interest on interest, right? Not much at the beginning, but eventually it takes off. Okay, so that number is now our starting point for the rest of the problem, where she plans to deplete her accounts. So she's turned 70. She has that amount of money, and for the next 30 years, she's wanting to take out money each month to live on, but she needs to make sure that the money's going to last all the way until she's 100. Okay, so, one way you could think of it to start with would be to take that amount of money and to divide it up by 30 years. Well, we want to do months actually. So divide it by 30 years, then divide that by 12, and then it just divides into little chunks. However, while that money is in the account, it's still gaining interest. So if she does that method where she just divides this by, it's actually 360, 12 times 30. If she just divides it by 360, she's still going to have money at the end of it because there's this interest that was growing. Okay, and at the beginning, there's a lot of interest that's growing on it. It's as it becomes smaller that it's less interest. So she'd really be shortchanging herself. In fact, let me just do that calculation because I don't have it written down, but I know it'd be a good comparison a little bit. Okay, so if I divide that by 30 months and 12 months a year, that's 360 payments. Okay, I get that number. So an even split of that. But if she uses it, she's still gonna have a lot of money at the end that she didn't take advantage of, which is interest that was being earned. Okay. This is, maybe the first part is a little bit more tricky in like choosing your formula because you had to go back to 4C. And then the second part now is bringing us into 4D. And this is kind of weird because it's not quite a loan that she's using, but we are going to be using a loan payment formula. That's weird, right? Okay, but it's because she has an amount that she wants to achieve. That even sounds weird because she already has the money. Okay, but what she's going to be doing is using up money little by like a certain amount at a time until eventually this goes down to zero. So you can kind of imagine that way as a loan, that the loan is already there and it exists and we want to get it down to zero. So that's the main thing here, is there's an amount of money that we want to get down to zero. So that tells us that our loan payment formula is the one that we want to use, which is from this set of notes. And I don't know where I put that page there. There you are. This is the one, right? Yeah. All right, so this is the loan payment formula. Title right there for me, that we're going to be using in this part. So again, it's guided you. It's helped you out to know which one you're supposed to be using. All right, so years is going to be 30 years. APR, same thing. Payments, that's what we don't know. We want to know how much money can she take out of her account every month and be fine. Okay, now your end's going to change because she's taking the money out every month. It should say that somewhere. Yeah, it says way up the top. Okay, want to make sure I got that part right. All right, and the original principal balance that we have, sort of like your $10,000 loan, is going to be the money that she accumulated during the first 44 years. Okay, so once we figure out what formula it is, the rest is pretty much just there for you. You get it all filled in. Hopefully you have a decent calculator that you can use to get through all this, because there's a lot of small pieces in it. But you can break it down into parts if you want. The very last thing is always going to be whatever that is, multiply by this number. So you don't do anything with that number until you figure out what all that is, and you multiply it. And look what we end up with. We end up with $2,553 and change. That if she withdraws this amount every month, she is still going to have enough money for 30 years. So you remember a little earlier I did this as an even split, like divided up. Look at the difference in the values here. This is only $1,000, 66 bucks. This is more than double what that one is. And it's because at the beginning when she's withdrawing money, even if she's withdrawing that, there's so much amount in the account, right? You still got $380-some thousand that's going to gain a lot of interest within 1 month. So then that amount of money is allowed to spread out into all these other payments in there. So pretty neat one there that that we get to see. All right, question number 20. What this is going to do is highlight the amount of interest that Sherry has earned by going through this whole process. I know I talked a lot about like interest on interest and how it grows in here, but now we get to see just a solid set of numbers of what happened. Okay, the A part one is a little bit easier to understand here. So this is just when she's saving the money. Okay, right here is how much money she actually puts into the account. Right, she takes $50 and she puts that into the account 26 times a year for 44 years. So if you multiply all those numbers together, that turns out to be $57,200. That's how much money it feels to her as she puts it into the account. But the fact that she'd been doing this for 44 years, right, 26 payments, 44 years in a row, it actually grew with interest all the way up to that 3,800 or 3,083. Man, I'm saying that wrong. $383,000. You know the number there. Okay, which is way bigger than the 57,000. So if you subtract, you get 326, etc. That's how much interest was earned just in the first part of the savings, right? She only put that much amount of money in there, but she's walking out with about 6 times as much money than she had there. So a lot of interest earned. All right, the next part is a little bit confusing with it as well, but for the 30 years that follow, every month, 12 times a year, she withdraws $2,553. Okay, in that calculation, I didn't actually work out. So let me type that in real fast. 3.72 times, that's not times, 360 those together. Okay, $919,000, so almost $1 million is what it feels like she's able to spend over the next 30 years, or she is. It's not, she feels like that's what she gets to spend. But remember that, so she gets to spend that amount of money over 30 years, but she only started with this amount of money at that time. So if you subtract those two, you realize that she had gained in the process of doing it slowly and letting the interest grow. She actually gained over $500,000 in interest. So grand total from 26 all the way to 100. Okay, so over the 74 years, if you add that interest plus this interest, it looks like in just interest alone, $862,000. So nice chunk of change for saving it that way. All right, D, I didn't even go ahead and answer because the answer is going to be the same thing that's here. It's just a different perspective of looking at it, and I don't want to even bother with it. I knew the answer was going to be just that number anyway, so I'm going to skip over that one. All right, and at the end, we got some quick questions here. Most of this I already kind of hinted to, and I even said that I remember that it was at the end of the activity somewhere. We'd get to it. All right, so 21, for scenarios that use the savings plan formula, the balance will start at 0 and the payments will increase the balance. So that is the first part of Sherry's situation here. She starts at $0 and will eventually get to there by making these payments. Okay, for the scenarios where we do the loan payment formula, those balances, they start with a certain balance and you're gonna decrease with the payments all the way down to 0. Okay, and then Sherry's was a weird case in that one because it really wasn't a loan, but it was a way of applying it. So that one's more thinking of like if you borrow money for a car or a house and you make payments and you're trying to get the payments down to, get the balance down to 0. All right, 23. Oh man, that looks like a long one. For many people, it is necessary to borrow money in order to make purchases of for very expensive items like home or car. I've said all that. Most cases, the loans are fully blah, 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 which means that they are paid off or until they die, okay? In a series of fixed equal payments over a certain period of time, for the scenario, we would use the loan payment. Okay, that was really a long question, just to get to the same thing that we're already talking about, which is using the loan payment thing. But you want to pay it off. All right, 24. Let's see here, situations. All right, Maria has saved a lump sum of money and is now making period withdrawals from the account. So there's a lot of money in the account and she's just pulling money out of that. Okay. If the amount that Maria withdraws each time period is more than the interest accrued in the remaining balance, the remaining balance will deplete. All right, so there's a certain amount of money that's in the account and it earns interest. I think the second question is a little bit better. If she withdraws, the amount that she withdraws is equal to the interest rate. If she withdraws whatever was made in interest, then you always have the same amount of money that's in there and it's always gaining the same amount of interest every month and it would just go on forever. Okay, it would just be the same process. We did a problem like that in 4C. So that one stays the same. Okay, if she takes out more than what the interest is making on the account, then you're gonna have less in the account the next month, which is gonna gain less interest rate and eventually depletes the account down to 0. Okay, and then on the other end, this would be the more ideal situation here. If you had this thing going on is take out less than what the interest is earning, right? So I'll go back to the $10,000 example, even though this would be like a savings issue. If you got $10,000 in the account and it makes $75 interest at the end of the month, don't take $75 out. Take something less than $75 out so that the next month you've got $10,000, a little bit more, okay? And then that'll gain a little bit more interest than you did the first one, more than $75. So then stay underneath that number, okay? And what's really cool about that is the sacrifice of not spending or not taking out the $75 at the beginning, you get a little bit more and you can actually get a little bit more the next month. The next month you could take out 75 if you wanted. But as long as you're getting more money in there to gain interest, it's gonna grow.